Good evening, dear students. Now, very good evening. Yes, welcome to the ACE Online. Welcome to the ACE Online as well as ACE Engineering Academy, dear. ACE Engineering Academy. Now, today's session we are going to discuss. Coming to myself, I'm Gnaneshwar. Okay, fine. Today we are going to discuss TSPSC Public Service Commission. Now, EC branch, TSPSC EC branch related. Okay, Polytechnic Lecturer. It is a government job, Polytechnic Lecturer. Now, here we are going to discuss important concept and questions. In total control system, each and every topic, what are the important topics and related expected questions. Okay, subject name is control system, very interesting subject. Now, and also scoring subject here. Very interesting subject as well as scoring subject. Now, coming to the first two, before moving to this one, first we will discuss what is the syllabus of the control system. According to TSPSC, now, okay, Polytechnic Lecturer, control system syllabus, now classified into year, chapter wise I am writing. Yes, this is the, okay, syllabus copy for the control system here. Syllabus copy, okay, syllabus. Basics of control system, block diagram, signal flow graph, time response analysis, Routh-Hurwitz method, root locus, Bode plot, Nyquist and polar plot, compensator, state space analysis. We'll discuss one by one, dear. We'll discuss one by one. Now, what are the important topics and expected questions from this one? Yes, you should be ready with the pen and paper, dear. Whenever the questions are given, now I'm going to give the end, try to solve along with me. Now, come on. First one, basics of control system. Here, what are the questions you can expect from the basics of control system here? Basics of control system means, first thing here in this one, transfer function. There are two formulas of transfer function. First one, Laplace transform output upon Laplace transform of input here. Laplace transform of output upon Laplace transform of input. Initial conditions assumed to be 0. Okay. And one more formula also transfer function, Laplace transform of impulse response. This is the second formula. IR means impulse response. If you want impulse response, L inverse Laplace transform of transfer function. That is the first thing we are going to discuss in the basics of control system. Later, what is a control system? Open loop control system, closed loop control system. In open loop control system, what is the gain? Gain is high, closed loop control system less gain. And difference between the open loop and closed loop, that is a major points we will discuss. And also in the basics we will discuss sensitivity topic, dear. Sensitivity means here, sensitivity for open loop system. Sensitivity for open loop system. Sensitivity for open loop system is 1. Very high. That is a very high, dear. Very high. Actually drawback it is a drawback, disadvantage. Means any parameter changes, how much that will affect on the system, 100% is going to affect. Coming to the sensitivity for the closed loop system. Sensitivity for closed loop system. But closed loop system, there are two types here, closed loop system. What are the closed loop system here? Parameter variation with respect to H, with respect to H, J and G. Now parameter variation with respect to G, okay, now overall gain M, that formula is 1 upon 1 plus GH. This is an important formula. Now, okay, here, this is very important, this formula. This is the sensitivity of closed loop system, parameter variation G. In the closed loop system, we have the open loop gain as well as feedback gain. And also, parameter variation with respect to HD, M, that is nothing but formula minus GH upon 1 plus GH. Okay, now entire chapter within the short important topics here. Okay, fine. These are the main importance in the basis of control system. Now we'll discuss some questions about the, okay, nice. The open loop transfer function with unity feedback system is given. This open loop transfer function is given. The poles of the closed loop systems are located at. The poles of the closed loop systems are located at here. This is the open loop transfer function I am writing here. Is asking given open loop system. Examiner is asking closed loop system. Come on. Yes. Here open loop system, this is the given is open loop system. Product of S into S square plus 2S. This is a given is open loop transfer function. Given is open loop transfer function. Given is open loop transfer function. Now what is a closed loop transfer function? Closed loop transfer function is nothing but G upon 1 plus G product of H. H is how much is given, G is given, H is how much is given here? Yes, unity feedback system here. Unity feedback system means H of S is 1 here. Unity feedback system means H of S is 1. So substitute here. Now if you do this one, we'll get the closed loop transfer function is S square plus 2S plus 1 after taking LCM. So that closed loop transfer function we can also write. What is the closed loop transfer function we can write here? Now closed loop transfer function, these are the TSPSC level. Very simple, easy question. Now S plus 1 whole squared here. So denominator part is called as a poles here, closed loop poles here. What are the poles here? E equal to 0. So there are 2 square S equal to minus 1 comma minus 1 here. Open loop system is given, examiner is asking closed loop system, poles. So nicely the options are minus 1 comma minus 1, option C is perfect answer. Sometimes what happens, examiner is going to give the closed loop transfer function, is going to ask the open loop transfer function. That formula is closed loop to open loop here. What is the formula? If the question is given closed loop, what is open loop transfer function? Open loop transfer function from the closed loop transfer function. This is a closed loop transfer function upon 1 minus closed loop transfer function here. It is a one more different model. But here formula, given is open loop, asking closed loop. Sometimes reverse. Given closed loop is going to ask the open loop. So use this formula here. Now, yes, this is a TSPSC level. From the previous paper analysis, I am writing expected question and I also selected some of the previous questions. One more question, the transfer function of a system is given. This is a transfer function of a system is given. What is the examiner is asking? The impulse response of the system is, now impulse response, these are the options here. These are the options here. Okay, now try to solve. What is impulse response? Just now, impulse response equal to L inverse of transfer function. This is a formula. Formula for impulse response. Now L inverse of transfer function. So this is a given transfer function. Now before moving to the inverse, first of all we have to find the partial fraction. A upon S plus 1 plus B upon S plus 2. Now find out A comma B value. To get the A value, substitute S equal to minus 1, except this one. Except this one, substitute S equal to minus 1. Minus 1 plus 2. So no doubt A value equal to 1 only. So no doubt A value is 1 now. To get the B value, substitute S equal to minus 2 here. Substitute S equal to minus 2 where? S equal to minus 2. Now here, except this one S equal to minus 2. Minus 2 plus 1. So what is the B value? Minus 1 here. Minus 1. So B equal to minus 1 here. Partial fraction, B equal to minus 1. Now substitute here. Transfer function of the system equal to 1 upon S plus 1 minus 1 upon S plus 2. Impulse response of the system equal to L inverse of transfer function. L inverse of transfer function. So apply the inverse here. Now L inverse of 1 upon S plus 1 minus L inverse of 1 upon S plus 2. So if you find this one, impulse response of the system, we will get impulse response equal to 1 by S plus 1 is nothing but e to the power of minus 1 into t u of t minus e to the power of e power S plus 2 na. Here in the S domain plus means time domain you will get the minus. So e power minus 1t plus minus e power minus 2t. What is the suitable option here? So option D is correct answer. So transfer function of system is asking impulse response of the system. Okay, fine. Now, okay, this is a question. This is the answer here. Now, one more question. The unit step response of a system is given. Output is given. Response means output is given. Examiner is asking transfer function of the system. For what input? Step input. Now, these are the options. Try to solve this one. Already given formulas. Now, come on, try to solve this one, dear. Yes. Okay. Shanta photograph, okay. Yes. Now, okay, yes. Come on, tell me. What is the output response here for this one? Try to, yes. Already I gave int here. Output is given, apply the Laplace transform. Input is given unit step. Laplace transform is 1 by s. So what you have to do? Come on. What you have to do here? Yes. Now we have to do, yes, one student got the answer. Come on. Just to output by input, Laplace transform output by Laplace transform input, you will get the answer. Check it. So first thing, I am writing the once again formula. Int I am providing transfer function equal to Laplace transform of output upon, this is a formula, Laplace transform of input. This is a formula. Initial condition should be 0, already given, initial rest. So that is nothing but output I am going to take C of s, input I am going to take R of s. This is a transfer function. What is given? C of t is given. So examiner is given output equal to response, given output C of t equal to 1 minus e power minus 2t, 1 minus e power minus 2t. Now come on, apply the Laplace transform for this one. C of s equal to Laplace transform apply, 1 means 1 by s, Laplace transform e power minus 2t, minus means here s plus 2, take the LCM, s plus 2 minus s upon s into s plus 2 dear. So finally what we got, okay, we got it, C of s equal to, yes, tell me, C of s equal plus s minus s cancel, C of s equal to 2 upon s into s plus 2. This is equation number 1. Now what is given input equal to? Given input equal to unit step input is given. Clearly unit step input, unit step here. Input R of t equal to what? R of t equal to unit step is given, unit step. For unit step, anyone tell me what is the R of s equal Laplace transform of unit step equal to 1 by s. This is equation number 2. What is the trans function equal to? Simple. Transfer function equal to C of s upon R of s. Equation number 1 by equation number 2. 2 upon s into s plus 2 upon 1 by s. 1 by s is cancelled. So answer is trans function 2 upon s plus 2. Perfect answer is, what is the correct answer here? Yes, correct answer is, now option B, check it. Option B is perfect answer. Option B is perfect answer. Yes, anyone is given? No, okay. Yes, Sai Teja, think positively. Yes, Sai Teja, your hard work, never go, okay? Now you have to prepare in advance. Don't think, okay, think positively, dear Sai Teja. Exam, okay, is it there? Exams are in future, okay, compulsory. Exam is going to conduct. Okay, now next, this option B is perfect answer. Next, we'll move to the one more question here. This is about the trans function related questions here. This, okay. Now, okay, block diagrams. What question you can expect from the block diagrams here? Mainly block diagrams, block diagram reduction rules, based upon the rules they provide. Previous in the YouTube session also I have selected one question. One video to one video I am selecting different models here. So what are the question you can expect? Block diagram rules here. You can expect block diagram rules. Block diagram rules. The question from here, 90% questions from find the overall gain, find transfer function of block diagram. Find trans function of given block diagram. Given block diagram. Okay, find trans function of given block diagram. These, okay, question you can expect from here. So simple logic how to find out these block diagram related problems. Now we'll discuss one question here. Observe. The transfer function of the following system is given by, overall trans function of the system is given by. Now what is the block diagram is given? Okay, this is a block diagram is given. Now these are the options here. These are the options here. Okay, nice. So the thing is, now same block diagram, here no space. I am moving to the next page here. Now check it. Take the LP here. Yeah. Now I am going to write the formula. You can give the answer here. This is the same question here. The trans function formula we have to write. Simple. If you use the, it is a one mark question. Competitive exam. So if you use the block diagram reduction rules, means it takes a lot of time. Simple technique here. Shortcut, simple technique. sum of forward path gains here. Sum of forward path gains upon 1 plus or minus sum of individual loop gains. Loop gains here. This is a technique here. Now it's 1 mark only, 1 mark using now loop gains here. Now what we have tried, this is a opposite sign here. This is nothing but opposite sign. Opposite sign. Okay. Now I am writing the answer for this one. Come on. Yes. Overall gain equal to C by R equal to, what are the forward path gains here? Now forward path gains, tell me. Yes. Yeah, correct. Now here, this is the input here. Sorry, from input to output is called as a forward path. What is the forward path here? We can write G1, G2. No? Forward path is G1, G2. First thing, forward path is G1, G2. Only one forward path we have. Okay, one forward path only we have. Then we have to go for the loops here. Loops means how to select the loops here. This starting point, ending point is same only. This is a loop only. But while writing loop here, this sign is there. Opposite sign you have to take. 1 plus G1 H2. Opposite sign of this minus, okay, G1 H2. Now next we are moving to the one more here. This is also loop here. Starting from here, okay, ending. Now tell me here, minus sign is there, opposite sign, plus complete in this one G1, G2, okay, G1, G2, H1 here. This is the transfer function of this question. Now no other loops are here. So select the suitable option here. What is the suitable option? Come on, tell me. Suitable option here. Now no doubt option B is perfect answer. To solve this one, option B, any students are given? Yes. Monica, wow, good. Dear, block diagram. While giving the answer, you have to mention block diagram answer so that I can identify easily, dear. Monica, you given correct answer. B, option B. Yes, correct. Okay, fine. Okay, fine. Next, this is about the block diagram. This question you can expect. You can observe the formula. This is the formula here. Any block diagram problems we can solve by using this formula here. That is all about block diagrams. Now each topic I have to touch the all chapters within 1 hour. Covering syllabus is a difficulty. So what are the expected areas? What are the questions expected? Important questions. Now signal flow graph, what question you can expect? Examiner is going to provide the one signal flow graph. He may ask the number of forward paths, number of individual loops, number of two-non touching loops. That type of question you can expect. Examiner is going to provide one signal flow graph. You may expect forward path, individual loops, two-non touching loops. That is one thing. And also one more question based upon the Mason's gain formula. That is overall gain. So the expected area here, number of forward paths here, number of forward paths you may ask, number of forward paths, comma individual loops, comma two-non touching loops. That is the one area. And also one more question, overall gain by using Mason's gain formula. Overall gain by using Mason's gain formula. Overall trans function. These two you can expect from the signal flow graph. Now we'll observe one question. Okay. Now first thing, the number of forward paths in the following signal flow graph is. Now I am going to provide one signal flow graph. So what are the number of forward paths here? Now come on, this is one of the previous question. Okay, nice. This is one question here. Now, okay, given options here. These are the given options. Small here, what is a small? This is upon here. This is not touching this one. This is not touching here. Actually, this is traveling over. This is the traveling on, okay. Now, yes, these two are not touching here. Now, come on, try to find out how many number of forward paths are here. How many number of forward paths here? Come on, help. Yes. Number of forward paths, simple. Number of forward paths here, yes. Now, here I am writing, yes, for this question, number of forward paths. Now tell me, while giving the reply, SFG related answer, SFG answer, options, SFG options. Yes, number of forward paths here. Come on, provide. Yes, Sandeep, option B, and Upendra, 3. Okay, both people are given same answer, 3, 3. Now, good. Good. Now, any other answer? Number of forward paths. Now, I am going to explain what is the number of forward path. Come on, try to provide. Input to output, how many ways we can reach? Okay, the path from input to output here. But does, okay, the path from input to output. Yes, how many ways? The small condition here without touching any other node 2 times. Sandeep, you have changed your answer. Again, option B, Sandeep, okay. Monica, 4. Okay, very good. Once again, I am telling, just sample point of view. Starting from input to output, how many ways we can reach? That is called the forward path. Once again, here, what is the forward path here? Starting from input to output, how many ways we can reach? That is called the forward path. Yes, I am expecting from remaining students. Yes, majority answers are 3. Good. This is a straight forward path. This is a straight forward path. That is a forward path 1. Second forward path also there. Second forward path. Second forward path here observe. So I am erasing this one. This is the first forward path, no doubt. Second forward path here. This is the second forward path here. Correct, na? That is the second forward path. Now, okay. This is the second forward path. Observe. This is the second forward path. First is a straight forward path. Now, as of now, 2 forward paths are completed. Now, third forward path, observe third forward path here. Is it forward path or not? Now, is it forward path or not? Let us. Yeah, fine. I am moving like along the mentioned direction. Yes, this is a third forward path. This is a third forward path. Once all people listen here, now this is not touching here. This is over. Okay, this is over. Both are not touching. Both are not touching means this is a third forward path here. No doubt. This is a third forward path. We need to travel along the direction. As of now, third forward path. Any other forward path is there? Now I am taking different color here. Different color. Is it forward path or not? Starting from here without touching any other node 2 times. Other loop, other node, other forward path touching, no problem. Yes, this is a one more forward path. So as of now, 4 forward paths here. Once again, I am erasing. So I am writing the 4th forward path here. Move like this, 4th forward path. Come here, it is not touching. Come like this. Now, okay, it is not touching any other node 2 times here. This is a 4th forward path. So as of now, 4 forward paths here. 4 forward paths. Yes, one student was given. Monica is given, correct answer. Monica is given, and last finally Mr. S also given. Wow. But majority people were given option B, no dear. So option D is correct answer. Number of forward paths are 4. Number of forward paths are 4, very good. SFG related. So, but while moving, every node should touch one time only. What is the forward path definition I am writing? What is the forward path definition? The path from input node to output node without touching any other node 2 times. Without touching any other nodes, okay, more than once. All nodes should touch only once only, okay, without touching any other nodes more than once. All nodes should touch only once, more than once. Only every node should touch only one time only. This is a 4th forward path, so it is a perfect answer. This type of questions are going to ask in the TSPSC Polytechnic Lecturers. Okay, especially TSPSC previous paper analysis. Now, okay, we'll move to the one more concept that is called as a Mason's gain formula, dear. This is called as a Mason's gain formula. What is a Mason's gain formula? We'll observe now. Yes, you have to learn the masses gain formula here. What is the masses gain? Now overall gain equal to formula for the masses gain formula. Important concepts I am providing. Okay, 1 to sigma 1 to k, p suffix k delta suffix k upon delta d. This is a masses gain formula. So what is a k equal to number of forward paths? P suffix k is nothing but kth forward path gain. Kth forward path gain. Kth forward path gain. Kth forward path gain. Delta is nothing but what? Delta is nothing but 1 minus sum of individual loop gains, alternate minus plus alternative, sum of 2 touching loop gains, alternate minus plus minus sum of 3 touching loop gains, and so on. Alternately minus plus minus and so on. That is the delta. K is number of forward paths. Suppose k equal to 3. This formula modified as a P1 delta 1, P2 delta 2 plus P3 delta 3 upon delta. Once again, where k equal to 2 means this formula modified as a P1 delta 1 plus P2 delta 2 upon delta. What is the delta suffix k? It is same as delta. Remove the loops which are touching to the corresponding forward path. That is a masses gain formula. Okay, masses gain formula. Next, related to this one, I am going to provide one question. Come on, use this formula. Find the overall gain, overall transfer function of the question. Okay, this is a key. Actually, this is a masses gain formula. By using this one, solve this question. Come on, try to find out. These are the options here. These are the options. Come on. SFG answer, SFG C by R. Int is SFG C by R. Come on. What is the answer here? Don't write ABCD. Simple. Okay, type it. Suppose answer is 15 by 15 upon something. You have to type it. Yes. Use this formula, dear. Use this formula. Same formula. By using this formula, how to solve this one? How to solve? Now, I am writing forward path gains here. Overall gain equal to C by R equal to, first of all, forward path. Forward path gain equal to, okay, 1 into 10. 1 product of 10 into 1. 1 product of 10 into 1. That is the forward path. Sum of the forward path now plus. One more forward path is also there. One more forward path. It is also forward path now. We can reach input to output now. Yes, this forward path is only 5. So plus 5 upon forward paths are completed. Forward paths are completed. Now after forward paths, loops here. Now tell me loops here. First loop is, this is a loop here. This is a loop, individual loop. While writing individual loop, opposite sign we have to write. While writing individual loops, one compulsory. 10 into 2. 2 is opposite sign minus. While writing individual loop, the technique is take the opposite sign. 1 minus. Okay, the reason here observe, minus is there na. This gain is minus. Minus and minus what happened? Plus only. That is the reason why for individual loop gains, what we have to take? Minus is there means we have to take plus. Why? Because minus of minus plus only. 10 into 2, this is a one loop. One more loop is also there. One more loop also there. That loop I am writing like this. This is also one more loop na. This is also one more loop na. That loop name is 5 into 2. 5 into 2 means minus. Minus means plus 5 into 2 here. So 10 plus 5, 15. 20 plus 10, 30, 31. So anyone give an answer here? Yeah, correct. Within short time. Yes. If you type, then only I can identify it here. Monica given 15 by 31. Yes. Sudhanshu Sharma is correct. Who is that? Durga? No, that is, no, 15 by 31 is correct answer. Option A is correct answer. So perfect answer is option A. Next, we'll move to the one more question. This is the expected question from the signal flow graph here. Now, next I am touching time response here. What is the time response questions here? We can, the unit impulse response of the system is given. Unit impulse response is given. Unit impulse means Laplace transform impulse, what will get? Transfer function will get. Transfer function will get. From this one, transfer function will get. For the system, steady state value of the output for the step input. Steady state. At steady state, what is the output is asking? Very important model. This model is very important. Now these are the options here. Come on. Yes. While typing, put the time response, otherwise steady state value, SSV. While typing, you have to type SSV, steady state value or steady state output. Steady state value or at steady state output equal to the formula limit s tends to 0, s into C of s. This is the formula, equation number 1. So we have to get the C of s here, but is given impulse response is given. So given impulse response is how much? Impulse response is how much is given? Impulse response e power minus t, e power minus 1 into t u of t. What is the trans function equal to? From this one we can get the trans function equal to Laplace transform of impulse response. Laplace transform means C of s by R of s equal to Laplace transform of e to the power of minus 1 into t u of t. So what is the answer? Come on, 1 upon s plus 1 here. From here I required C of s here. C of s equal to multiply R of s that side, 1 upon s plus 1 product of R of s here. So this is equation number 1. What is given? Step input is given. Given here, observe. Unit step input is given. For unit step input, what is the for unit step input? Given unit step input. So for step input R of s equal to how much? 1 by s. Substitute in equation 1. Substitute in equation 1. So what is the C of s will get? C of s equal to what we will get? Come on, tell me. C of s equal to, substitute all this one. Substitute all this one. What is the steady state output equal to? Steady state value equal to limit s tends to 0, s into C of s. Now limit s tends to 0, s product of C of s. C of s equal to how much? 1 upon s plus 1. Product of R of s equal to how much? 1 by s. 1 upon s. So SS cancel. SS cancel here. SS are going to cancel. Wherever s is there, s tends to 0. So no doubt steady state value answer equal to 1 here. Steady state answer 1 only. Steady state value on 1. Yes, Sandeep Sonu, within short time you given, and Sharma also given. Only 2 students were given. Correct. Steady state value is correct answer is 1. Perfect. This is a very important model here. In the TSPSC previously asked this question. Now no doubt option C is correct answer. C is correct answer. This is a time response related question. Time response related. In the time response, what type of question you can expect here? What type of question you can expect? This type of one question. And moreover, mainly they are asking steady state errors here. Steady state errors. Steady state error for unit step, steady state error for ramp input, steady state error for parabolic input. Mainly steady state error for step input only. Okay, and that is the one thing. And the questions on the delay time, rise time, peak time, percent type MP. That are the questions they are asking here. Okay, fine. Now next to yes, that are the questions they are asking. Stability analysis using Routh-Hurwitz. Each and every chapter important to concept, important topics, and one question. Here in this RH method, the examiner may ask the question. They provide characteristic equation. They provide the characteristic equation and are going to ask number of right side poles, left side poles. That is the question. And poles are imaginary. That is the one thing. And second thing, conditional stability. Conditional stability. The range for k values. They will provide the range for k values. Range of k values for stability. Okay, range of k values for stability. K values for stability. Now this model is important. Yes. For stability, what are the range of k values? Okay. Now this is these two models are asking from the TSPSC previous paper analysis. Now we'll observe one question. For time being, I am selecting one question. The number of roots of the characteristic equation. Examiner was given characteristic equation. Right side poles is asking. That is the RP. These are the given option. Very simple question. Characteristic equation is given. Come on. Yes. While writing, you have to put the type RP, right side poles equal to dash. Then I'll identify. Don't give the option simple. Don't give the options. So it is I can, simple write RP equal to, that answer so that I can identify. Now dear, come on. Steady state value means we have to find the steady state output here. Steady state value different to KP different to steady state error in the question paper. Hello, Durga Prasad, I think your typing is wrong. SSCE means you put, okay, you gave the reply SSV, but Prasad, okay, Durga Prasad, if the question is SSC for step input means find the KP. SSC for ramp input means find the KV. Okay, fine. Wow, Monica, yes, you are right, 2. RP equal to, na? Yeah, correct. Now this is a given characteristic equation. I am writing the characteristic equation here, RH method. Here, note down. Now highest power, the method starting with S power 4, S power 3, S power 2, S power 1, S power 0. Now this coefficient is 1, alternative. This coefficient also 1, alternative 1. Now next odd number 4, alternative 8, no alternative 0. Now tell me here 1 into 4, 4 minus 8, minus 4 by 4, minus 1. Okay, these 4 elements, out of this 4 element, this element is 0. So obviously next above element 1 only, above element. Otherwise you can multiply 4 into 1, no, minus 1 into 0 upon 4, you will get 1 only. Now next thing, minus 8 minus 4, minus 8 minus 4. So minus 12 upon minus 1, so plus 12 only. This element is 0, above 0 element is 1 only. Now here notice, this is a positive, this is a positive, this is a negative, this is a positive, this is a positive. Positive to negative 1 change, negative to positive 2 change. So number of sign changes here 2. Number of sign changes. Actually number of right side poles equal to number of sign changes equal to 2. So correct answer is 2 is correct answer. Number of right side poles equal to number of sign changes in the first column. So correct answer is option B is perfect answer. Option B is perfect answer. Yes, Monica, Sandeep, correct. Now next, yes, that will improve your confidence level. This about the all about the Routh-Hurwitz method. Now next part we'll move to the root locus. In the root locus, what question they're concentrating mainly they'll ask the find the centroid, that is the one thing, and also angle of asymptote. Okay, previous question break point and intersection point, but angle of departure they are not asking. The angle of departure is a lengthy question. In TSPSC they are not asking previously, but these questions are asking. These are the asking, okay. But one time read it, angle of departure also. It is a 2 marks question, lengthy. These questions are asking centroid, angle of, okay. By analyzing the previous paper, these questions are concentrating. Now we'll see one question on the break point. A unity feedback system has a forward path trans function. Now this trans function is given here. Okay, the break point lies in between. No sincerity is required here, simple technique here. Now these are the options here, First I'll move to the, okay, next page. Now here, otherwise here only observe. I am writing. Now what are the poles here? 3 poles are there, na? So I am indicating the poles here. At S equal to 0, 1 pole here. At S equal to 0, 1 pole. At origin, 1 pole is there. At minus 4, 1 more pole here. At origin, 1 more pole. No need to find sincerely. S equal to minus 5, there is 1 more pole here, dear. We know, yes, in between, to exist this one, it should be odd number. Any point selected this one, it is in the odd number. So it exists in the root locus branch. It is on the root locus branch. Okay, any point this side 1, 2, 1, 2, so it is a even number. Even number means it is not a root locus branch. Any point selected that side, so it is a total number, odd number. Why? Because 1, 2, 3, it is on the root locus branch. It is a root locus branch. So we know at S equal to minus infinity, there exists a 0. Assumed 0. So happily this pole reaches this 0. So this pole is not required, okay, this pole is meeting on the real axis only. These 2 poles never meet the zeros on the real axis. They must leave. So break point one logic, it never be, okay, always it is on the root locus branch only. This one is not required. only the breakpoint exists in between 0 and minus 4 only. Between 0 and minus 4 only, breakaway point exists. Breakaway point exists. Simple technique. Whenever two poles are adjacently placed in between root locus, then there exists a breakaway point. So breakaway point compulsory between 0 and minus 4. 0 and minus 4. Correct option is okay. D is right answer. Any options are given? Yes. First student Monica and Sandeep also given, all people. Sunita, wow, good. Upender and Durga Prasad Chari. That will improve your confidence level, dear. Very good. Very good. Before my explanation only you have given answer. Nice. Yes, this is the logic. These are the questions from the previous questions here. Okay, fine. Yeah, fine. Let us. Now, what is the question? Which of the following is the time domain analysis method of the control system? Nyquist diagram. It is a frequency domain. No doubt it is a frequency domain. Why? Because graph with respect to omega. Now, root locus will check it. Bode plot. It is also frequency domain. Bode plot also frequency domain. Now, next to polar plot. It is also frequency domain. Why? Because graph with respect to omega. Now, next one. Yes. Polar plot also, okay. So obviously root locus and RH method, Routh-Hurwitz method are the time domain method Examiner is asking time domain methods. So correct option is B is a time domain method. Root locus is a time domain method. Remaining are what we call frequency domain methods here. Okay, nice. This question you can expect from this one. Now, okay. Yes. What are the questions from the Bode plot? We'll observe. What are the questions from the Bode plot? Yes, dear, Vamshi teaching in Telugu. Yes, dear, many people are watching. Other state people also watching dear. So that is the reason why I'm using English. Now, okay, fine. Anything you're not catching means just to post me dear. Bode plot. From the Bode plot, what are the questions they are going to ask? Bode plot lo emi question edutaru. Now, chudam ippudu. Now, mainly the questions from, let us gain margin, pays margin, the questions, and also minimum pay system, non-minimum pay system, minimum pay system, non-minimum system, alpha system. Minimum pay system means all poles and zeros should be left side. Non-minimum means at least oka zero right side. Alphas means pole is left, zero is right, both are symmetrical. That is alpha system. And the question related to the inverse Bode plot. Inverse Bode plot ante examiner Bode plot istadu. We need to find out the transfer function. That is the inverse Bode plot here. Bode plot question istadu. Manam transfer function find out cheyala. That is called as the inverse Bode plot related question. Now we'll observe on the Bode plot what is the question is given. A system has 12 poles and 2 zeros. Its high frequency asymptotes in magnitude plot will have a slope of. Previously observed the question paper, so I have selected one question here. In the previous videos, I have done this last 10 days, 2 videos. In that, I have selected different models. Here I am selecting one more different model. Yes, this question, now, okay. These are the options are given. Now, at high frequency, what is the slope? Slope at high frequency. Slope at high frequency, the formula. High frequency, the formula is number of poles minus number of zeros, product of into minus 20 dB per decade. Here, what is the given poles here? Poles is given 12. Here, given poles is how much? Number of poles is 12. Number of zeros are given 2. Number of zeros are given 2. So, substitute here 12 minus 2, product of minus 20. So, 10 into minus 20, minus 200 dB per decade here. This is a TSPSC. Now, okay, fine. Now, what is the answer here? Minus 200 dB per decade. Option C is perfect answer here. Option C is perfect answer. Correct. Yeah, Lohit, we are also don't know here. But meanwhile, everything we need to think positively. మనం పాజిటివ్ థింక్ చేయాలా. సో పాజిటివ్ థింక్ మీన్స్ ఎగ్జామ్ ఓకే డిలే అయ్యే కొద్దీ యూ హ్యావ్ టు ఇంక్రీజ్ ద ప్రిపరేషన్ అండ్ ఇయర్. డోంట్ బీ డిసప్పాయింట్. 100% ఎగ్జామ్ ఉంటుంది, 100% ఎగ్జామ్ ఉంటుంది. బట్ యూ హ్యావ్ టు థింక్ ఇన్ పాజిటివ్ వే. ఐ గాట్ ఎన్ ఆపర్చునిటీ టు ప్రిపేర్ మోర్. సో అలా థింక్ చేసి ప్రిపేర్ కండి. ఓకే నౌ ఎస్ శరత్ లోహిత్, ఎస్ ఇట్ ఈస్ నాట్ ఇన్ మై హ్యాండ్ ఆల్సో, నాట్ ఇన్ యువర్ హ్యాండ్ ఆల్సో. సో ఇన్స్టెడ్ ఆఫ్ డిసప్పాయింటింగ్, డిప్రెసింగ్, so we have to think, yes, I got an opportunity to prepare more. You can prepare happily, dear, nicely. Yeah. Next. That is the one question here. Yeah. Inverse Bode plot related one important information I given. If initial slope is increases, there is S term present in the numerator, trans function. If initial slope decreases, then S term present in the denominator. If initial slope is 0 dB per decade or constant magnitude, then no S term present in the numerator and denominator. This is an important information related to the inverse Bode plot here. Inverse Bode plot. Okay, fine. Next, Nyquist plot. Nyquist plot, polar plot together. They'll ask the questions mainly. Number of encirclement with respect to origin, that is a one type question. Number of encirclement with respect to -1 plus j0. These are the questions are asking previously. Number of encirclement with respect to origin, one different, okay. Number of, both are look like same, p minus z only, p minus z only. Both cases p is same only, number of open loop holes, number of open loop holes. Here z means open loop zeros, but z means here closed loop. This is a closed loop holes here in this formula. So I will provide that related formula. Yes. First, which statement is incorrect, not correct, relation to the Nyquist and Bode plot? First thing, common property, both are frequency domain. First option will observe. Number of closed loop poles in the right of S plane can be determined by using Nyquist plot. Correct only. This is a correct statement. Nyquist plot use చేసి మనం రైట్ సైడ్ పోల్స్, రైట్ సైడ్లో ఎన్ని పోల్స్ ఉన్నాయో ఫైండ్ అవుట్ చేయొచ్చు. సో వీ కెన్ ఫైండ్ రైట్ సైడ్ పోల్స్. దిస్ ఇస్ అ కరెక్ట్ స్టేట్మెంట్. ఇట్ ఇస్ అ కరెక్ట్. ఓకే, దట్ ఈస్ అ ఓకే కరెక్ట్ స్టేట్మెంట్. Bode analysis uses two plots. One is magnitude plot, one is phase plot. Correct. Bode plot draw చేయాలంటే two. Magnitude plot below phase angle plot. Two separate globe. Okay, magnitude plot to phase angle plot. It is also correct statement. Now next, Nyquist plot analysis uses polar, okay, two plots, one for magnitude, one for phase angle plot. No. Nyquist plot single graph lo both magnitude, phase angles. What is a Nyquist plot? Magnitude, phase angle versus omega. So Nyquist plot లో టూ ప్లాట్స్ అవసరం లేదు, సింగిల్ గ్రాఫ్లోనే మ్యాగ్నిట్యూడ్ పేజ్ యాంగిల్ మెజర్ చేస్తాం. దిస్ ఇస్ రాంగ్, దిస్ ఇస్ ఇన్కరెక్ట్. నౌ నెక్స్ట్, రిలేటివ్ స్టెబిలిటీ కెన్ బి ఓకే డిటర్మైన్డ్ బై యూజింగ్ బోత్ Nyquist and Bode plot. Yes, relative stability. Comparison of one stable system with other stable system, that is a relative stability. It is also correct answer. It is also correct statement. Not okay, correct statement dear. This is also correct statement. But examiner is asking what? Come on, incorrect statement. Incorrect statement. Incorrect means this Nyquist plot is an incorrect statement. This is an incorrect here. This is an incorrect. This is an incorrect. So select the incorrect answer, option C. Okay, fine. Next. Okay, Sharath Lohit, I can appreciate. You have the strong, solid, okay, basics, I think so. Very good. IAC Bangalore. Okay. We'll talk later, dear. We are in the live here. Okay, I'll give them my mail ID. You can talk personally. Now, I can appreciate, okay, you are a top. I think you have the solid basics. For you, it is not a difficulty to prepare. Okay, dear. Now, yes. Next, we'll move to the one more question, dear. Yes, one more formula here, what I am writing. This Nyquist stability criteria. Now, okay, fine. A unity feedback system as open loop trans function. This open loop trans function is given. Number of times the Nyquist plot of G of S encircle the origin. Origin. So, related formula. First thing, wow. Here I am providing the formula. Number of encirclement. There are two formulas we have. Number of encirclement with respect to origin and number of encirclement with respect to -1 plus 0. This formula used for closed loop system stability. For closed loop system stability, Wherever first formula used for open loop system stability. Open loop system stability. So both only difference is Z only. Here Z is or zeros, but here Z is poles here. That is only difference. Z means poles, closed loop poles. Here the question is what? Is asking number of encirclement with respect to origin here. Origin is asking. So origin means which formula is suitable? This formula is suitable. First thing, number of open loop pole right side. How many number of open loop pole right side? Come on, tell me here. Number of open loop pole right side. Indicate the poles and zeros here. So S equal -2, 1 pole. S equal -3, 1 pole. And S equal +1, 1 pole. Number of open loop pole right side. Number of open loop pole at right side. P means number of right side poles. So P equal 1. Number Z means number of open loop, okay, right side zeros. No zeros. So Z equal 0. So what is N 0, 0 equal to P minus Z. P equal 1, Z equal 0. So N origin, number of encirclement equal to 1 is perfect answer. Number of encirclement is equal to 1s. Number of encirclement equal to, okay, 1s is perfect answer. 1s. Yeah, okay, compensators will observe. One more topic, compensators. In this compensator, you may expect yeah, Sharath for you, no problem, dear. Okay, this exam easy for you only. Yes, I'll give the mail ID at the end. Just wait a moment. Compensator, they'll ask the lead lag. Lead lag, the properties. I'll give the conclusion short notes here. The phase lead compensation are used to, okay, increase the rise time and decrease the overshoot. Okay, both here. These are the option C, option D. Now check it. I concluded what are the effects of lead compensator. From that effects, shortly, beautifully I have provided, observe. Okay, nice. These are the effects of lead compensator. In lead compensator, given question underline, rise time decreases, peak overshoot decreases. Both are decreases here. Okay, this highlighted, na? This highlighted point observe. This highlighted decreases. This also peak overshoot also decreases. Both are decreases only. These are the effects of lead compensator. Now read perfectly. Effects of lead compensator. You can note down also. In short point I have given. So both are decreases here. Both are decreases. So okay, decreases both here. Option B is correct answer. So once again I am providing lead compensator effects here. Similarly, not only lead, lag also I am providing. Note down lag also. Next slide. Lag also. Yes, these are the lag here. Now lag. One time question was given. Which of the following compensator reduce the speed? Lag compensator. That is the reason why I underlined here. Okay, na? Now within the short time I am providing maximum content here. Useful information. Now you can copy, note down. Yes, fine. Now we'll move to the last chapter there. Yes, state space analysis. This is a state space analysis, last chapter. Here, what is the questions are asking? Generally, they'll ask the transfer function to find the transfer function and state transition matrix. Next one, controllability and observability. We'll see one topic about the controllability observability. Yes, this A matrix is given, this B matrix is given, C matrix is given, is asking controllable and observable. Now, how to find the controllable and observable here? Controllable and observable here. Yes. For controllability, okay, this x dot equal to what here? Come on, tell me. Ax plus bu. This is a y equal to cx plus du, 0. C equal to this one. For controllability, what I have to write? Controllability formula. Controllability. This is a controllability formula here. Controllability, MC equal to we have to write B comma AB. Previously question was asked directly what is the controllability formula. Now for controllability, multiply A into B. A into B. For controllability, det of MC, M means okay, matrix C controllability not equal to 0. If det MC 0 means, that is not controllable. If det of MC is 0 means that is not controllable. But in this question, after finding mathematics matrices, you will get det of MC 0. Det of MC 0, here det MC 0 you will get. Here in this question you can find out det MC 0. So okay, fine. That is about the controllability. Observability, what to do? Observability means this is a formula for observability. Observability formula according to Kalman's test. Observability, this is a formula. M naught equal to C transpose A transpose C transpose. Transpose, interchange the rows and columns. Yeah, if data of MC, if data of M naught not equal to 0, then it is a not observable. It is not observable. Sorry. Okay, it is a data of M naught equal to 0. Yes, it should be not equal to 0, then it is a 100% observable, completely observable. Okay, if it is equal to 0, if data of M naught equal to 0, then it is, we can say that it is a not observable. Not observable. These are the formula, dear. I have written the formulas nicely. Now, yes, anyone got it? Yes, one student gave the correct answer. Jirupala Sunita, not controllable but observable. Excellent, dear. Very good. Yes, super. Sunita, that indicates remaining people, you can understand the competition level. Yes, students are preparing very fast mode, give an answer. So for this question here, what we can understand, data of MC 0, data of, if you find data of MC 0, so not controllable. You can find out mathematics only, controllable, not controllable. But if you solve this one, data of M naught observability not equal to 0, so completely observable here. So best suitable answer here, I gave the formula. So the system is not controllable but observable. So what is the formula you have to use? This is for controllability, this is a formula. And I am showing observability formula, this is observability formula. Yes, correct. Correct. Next, okay, almost all, maximum all models covered. It is a 1 hour time, dear, 1 hour, within 1 hour covering all this one. Maximum I have covered. Now we'll go for one more question. Okay, let us. A system is given like this and is asking state transition matrix. State transition matrix formula I am writing. State transition matrix formula, simple. State transition matrix formula I am writing. L inverse of. L inverse of. Now you can find out L inverse of, and later after L inverse, then we have to write Si minus A inverse, dear. Si minus A inverse. Si minus A inverse. Here. Now, Si minus A inverse formula I am writing nicely. This is the transfer function, okay, state transition matrix formula. After finding, then no doubt you can solve it this one, you can solve it this one. So we will get what is the state transition matrix formula. Now first S into I you can write. S means here A matrix is given, this is A matrix. This X dot equal to AX plus BU, dear. I think B matrix is not required for us, only Si minus A. A equal 2 cross 2 matrix. Simple Si minus A, how to write Si minus A? Here this is Si minus A, na? Si minus A. S I matrix means 1 0 0 1 minus A matrix. So that is nothing but Si minus A equal to S 0 0 S minus A equal to A matrix equal 2 0 0 2. So Si minus A equal, what will get command? S minus 2 0 0 S minus 2. Then find the inverse matrix. How to find the inverse matrix? Yes, tell me. Si minus A inverse equal to, now okay, 1 upon AD minus BC, na, S minus 2 whole square. Okay, AD minus BC, 0 into 0 0. Interchange the diagonal elements, S minus 2 0 0 S minus 2. So division, after division what is the answer you will get? 1 by S minus 2 0 0 1 by S minus 2. Apply the inverse Laplace transform. Apply the inverse Laplace transform for this one. Why? Because formula is what? L inverse, na? Then you will get the state transition matrix equal to, inverse means 1 by S minus 2, na? S minus 2 means e power plus 2t, 0 0 e power minus means plus 2t, dear. So what is the best suitable option here? Come on, hello. Now best suitable option. Best suitable option is now e power plus 2t, e power plus 2t. Option B is perfect answer, dear. Option B is perfect answer. So from the state transition matrix, okay, fine. Now, yeah, many students are asking general doubts. Sir, will the exam is going to postpone or what to study? Okay, dear, yes, don't stop your preparation. Don't stop your preparation, continue. Now, and also as a ACE, we are providing free YouTube session. You can search. Now, okay, if you want more content here, if you want more content, yes, fine. I'm providing my contact details. Myself is Gnaneshwar Gaud, ACE Academy. Now, here observe mail ID. This is my mail ID. Yes, mail ID. If you want more data, you can search the previous videos. Many videos are there, my videos in the control system. You can search in the YouTube session. This is by searching Gnaneshwar Sir control system. Okay, Gnaneshwar Sir control system. Okay, dear, I hope now you will prepare. I think this information is useful. Now you will prepare and you will write the Polytechnic Lecturer and you will get the government job. So, okay, all the best. Yes, dear, God bless you. Now I am closing the session.